we're going to have fun with them. That's how I call it, fun. Okay. You guys ever done logs before?
Yeah.
I think you did some of this a little bit.
Algebra 2. Algebra 2.
Algebra 2. Okay, so why do we use logs? Okay, first and foremost, we are going to be working with logs and natural logs. You're going to want your calculator out for this funness that we're working on. Okay. Tall. All right. So you are able to use logs and natural logs interchangeably. Okay. You might find yourself having a favorite. I actually have a favorite. It's the natural log. But we'll kind of talk about that and how you will interchange and how they're effective. Okay. So why would you want to use a log in the first place? What good does it do us? Let's say I have 4 is equal to, well, let's go with something bigger. 8 is equal to a to the 3rd power. Okay? So if I am looking at this, I hope that I naturally know that 2 to the 3rd power is going to give me 8. Does that make sense? Mm-hmm. So if it's natural, it's something we can kind of work with, we're pretty good with that. But what happens when I start working into something that looks like this? So let's say I have a 5, and that is equal to 2 to the what power? It is not so easy to look at. Like if it was a 4, it'd be 2 squared. If it was an 8, it would be 2 to the 3rd. But how does it happen when I'm trying to solve for an x that's it's an exponential power when it's not so easy? So there's 2 alternatives to working this type of problem. You can use what we refer to as logarithms or natural logs. Your calculator actually does both, and we're going to kind of explore both. So the way you go about doing this is you use some of the properties that we have for natural logs. And so let me give you, I don't like the way they write them, but we're just going to go with it. They have multiple ways to work with logs. So if I have y is a to the x, then x is equal to log of a y. Okay, so if I'm looking at this from the perspective of trying to solve 5 is equal to 2 to the x, I'm going to look at this and say, okay, so what did they do to get it to look like this? On a personal level, I don't like to memorize that particular property. What I like to do is kind of a technique that works every single time. So I'm going to look at this thing and I'm going to say, listen, I want to get the x out of the exponent. So one of the properties that you could potentially use if I have y is equal to a to the x is if I natural log both sides, or if I log both sides. Okay, so there's 2 options. You can use natural logs or you can use logs. And I'm going to show you how they kind of go back and forth between the 2. Now, the property says that if I have an x that's an exponent, and I have a natural log in the front of that number, the property states that I can take the x out of the exponent and drop it to the front. So this can be rewritten as the natural log of y is equal to x, the ln of a. See, I told them it has a funky sound, and the guy came in and didn't have that funky sound. But you hear it, right?
Yes.
Okay, so it's not just me. Okay, so then, same concept. concept here. Instead of that, you could put the x down to the front and rewrite it as such. So how is this going to help me? If I was doing that 5 is equal to 2 to the x, I am going to use the natural log and the log. Let's play with the natural log and the log on your phone for a minute, okay? Natural log is what we refer to as base e. E actually has it's a value. So if you look on your little calculator and you find the letter E, what time is food pickup? 3:50. So on your little calculator, I want you to do something like the natural log of 2, ln of 2. So look for the ln button. I don't know where they're located. You find them on there. Sometimes they're hidden, like as a second, you have to do the second of something. But it totally depends on where it's located on yours.
Oh my gosh.
Oftentimes it's located around the LOG button. Are you finding it?
Oh boy. Will it be to 2 or 3
Did you
dozen?
find it?
What's the answer?
ln of 2? What is ln of 2?
0.6931.
That is correct.
Then no, I don't know.
No?
No, I don't know.
It's right here.
Oh,
Yeah, see, sometimes they're like
Right
right there.
in front
I get it, trust me. Okay, are we cool there? And your calculator naturally does what we call this base E. It actually does it for you, okay? And you can also do LOGs. Oh, LOG of 2. So go ahead and do LOG of 2 on there somewhere. Are you finding the LOG button?
That's a weird one.
How's it working? What do you get?
I have 2 inputs to
yeah,
put in.
it's two values.
0.301. Oh, you have 2 inputs on yours?
Yeah.
So if you have, does it go like this and then this?
Yeah.
Okay, so logs, LOG, is at a natural base 10. So if you're having to put like that, put a little 10 in the little guy, and then the 2 here.
Okay.
Yeah. That's weird that they make you do that.
0.301.
0.301.
Alright, go.
Okay. So, what we're gonna do is we're going to figure out which one we would prefer to use for the interchangeable options. So let's look at, for example, just work with LOGs for a minute. This is why I'm surprised that's a Casio class Wiz. Oh, that's funny. So if I never put something here, it's a base 10. Okay, so let's say I have log A, B. Okay, something other than the number 10.
I'm just kidding.
Yes.
The classroom does have a regular log button.
It does?
Where?
It's a shift button, so it's the negating sign, but you click shift and then you click it and then it's.
And then you don't have to put the base
And
10.
then we have another one, which is the one you can put.
Well,
on.
you're gonna really love the other one.
Where's that one?
It's the negating button.
Oh, okay.
That's super cool. And let me show you why. So if you're working, if you're doing something that doesn't have a little base 10. So for example, let's say I have log of 2 of 3. I can't just plug log 2 of 3 in your calculator. You have to use, in normal people world, you have to use something called the change of base formula. Okay? And what the change of base formula does is it puts it into log base 10 because your calculator only knows log base 10. So the change of base, what's going to happen here is you're going to have the log of 3 divided by the log of 2. Log of the big guy divided by log of the little guy. Okay? So for those of you that have a class Wiz, you're going to just plug log little base 2 to 3 in there. For those of us that don't have the class Wiz, we're going to do log of the big guy divided by log of the little guy.
The regular
So-
Casio also
Has the thing that you plug in the tube? Oh my gosh, that Casio is like, it does everything but wipe your tush. Does anybody have a TI? Yeah, so TI people, that's the world I live in. Yeah, the TI, you're gonna have to change the base. You're gonna go log of 3 divided by log of 2, and that's gonna give you the very same answer.
Oh, it's right there.
Wow, that's so cool.
love Casio.
Wow. I'm a little like calculator envy. I never had a calculator when I was growing up. Just really do. How? How does it have so much power?
I don't
Okay,
know.
so what do you get when we do log of little 2, 3? 1.58? Give me 2 decimals out. 8? 5. I think that's what I heard. That's 3 decimals. That's what I heard. Okay, so now you know how to play with that. So let's go ahead and does natural log also have the little base guy with it?
No.
So, no. It likes logs better then.
It
The
does.
Casio likes logs better. That's okay. We'll be able to play with them interchangeably and I'll show you how that'll work. So, now, log of little a, b is equal to y. This is like a formula. Okay? So, oftentimes, you're going to not be given the a and the b. You're going to be looking, given a y, try to find an a or b, or given the y, try to find the b and you know the a sort of thing. So there's ways to take this, which is in a regular format, and rewrite it in what we call exponential format. And let me show you the little technique that makes this work. You're going to take the little guy a and you're going to raise it to this power, and it's going to be equal to this guy b. So let me show you what that looks like. A to the y, that's a y, a to the y equals b. Okay, so if I gave you log little base 3 x equals 2.5, can we solve for x? In its current form, I can't just plug this in my calculator and get a value because I'm missing this guy here. Where you see over here, I'm able to take log of 3 divided by log of 2, or you Casio class whiz people or Casio people, you can just plug it in your calculator, very jealous. So how do you go about doing this? You're going to take the little guy and you're going to raise it to this power, and that's going to be equivalent to this guy here. So literally you're going to take 3 to the 2.5 and that equals x, which is something we can do. So go ahead and plug that in.
What
What do you get?
15.58.
Is x. Let's give it a whirl and see if it does the job. If I was to plug 15.58 and change here, log of 15.58 divided by log of 3, does that give me approximately the 2.5?
Mm-hmm.
Yeah,
It sure does.
which is kind of cool, right? I say yes. Right. We all think so. Okay, so what about this guy? If I'm asking you to solve.
Sorry.
Can you do that without a calculator? Yes. How could you rewrite it in exponential form? What would that be? 2 to the x equals, so what, 2 to what power? 4. So your value is 4. However, if we can't figure that out, which is completely plausible, how am I going to figure out the answer if this is 4? You're going to plug this in your calculator, right? And some of you, some of me, that like the TI people, you're going to do log of 16 divided by log of 2. So log of 16 divided by log of 2 is the way TI people will work it. But my Casio people, you're just plugging in log 2 of 16. That is crazy to me. That's crazy. Can you use the Casio class whiz on the SAT and stuff?
Mm-hmm.
Wow. Yes. I'm a little jealous. Okay, cool. All right. Are we cool? Did you guys figure that out? We good? Try this guy. Try to do it without.
Is this in log of 3 or log of 8?
So that's a little 3. Sorry.
No,
Yeah.
you're good. I just can't see because
The glare. and Eddie, when he painted the room, my husband painted the room for us. When he painted the room, he, tried to put anyway, those were never up, they were always in the corner, so he tried to put at least in the center, so the glare would help, but that's where we're at. How are we doing on this one? Yeah? Do you wanna see how my brain makes it work? Yeah? So cause you know, the calculator was never something I used, I know 1/9 is really 3 to the -2nd. Does that make sense? 1/9 is 3 to the -2nd power. Is everybody cool with that thought process? Yes? So then my brain goes like this. 3 to what power, so because I called it like x, 3 to what power is 3 to the -2. Because remember, it's this to this equals this whole thing. So what is x going to naturally be? That's how I do it. But you all have calculators, which makes me really jealous. Although that's kind of a cool technique to be able to do. All right, let me make it fun for you then. No. Log of x, and then this is a fun one, the cube root of x over x. Yeah, that's right. Try it my way now. I'm gonna let you play with it for a minute. I don't see anybody talking to each other. Yay.
You just assume all the logs equal x. Okay, so it's red.
Is it big?
So,
Yeah, yeah.
yes.
Okay. Like for the log to little 3,
So,
you just assume that it equals x.
It kind of seems
Yeah.
like you, but you did x to x.
I don't like that.
You don't like it?
I don't like that. That's,
Or like, instead of, because this is all X, maybe make it Y, yeah.
I guess that was just hurting my brain.
yeah,
get
it's hard to see. I was like,
So, since it's all.
Trying to figure out where
like
everything
it's
went.
an X, all the way up. You see in parentheses, it's all some sort of an X to a base, or X is the base, so X is the power. So the top is X to 1/3, because it's a square root, right?
Yeah.
Or, because it's a cube root. You know, the bottom one is X to the -1.
How does it need
X to the
divided?
-1 since it's
Yeah.
a
I have x to the x.
Yeah.
Yeah.
So then I have the x
No,
that.
no, I'm just talking about, it is X to the X equals.
Are you guys having good
I
conversation?
think.
Yes.
Does it have something to do with like x being like
-2/3.
Say it again.
like x, you put x to the 1/3 and then multiply it by x to -1? Okay, I don't know if you actually.
Oh, that was so perfect.
Wait, that was right though? That was good?
Yeah.
Oh my god.
Yeah.
Because like,
X power, right?
So you guys agree X, this is X to the 1/3,
apparently.
and that's over X. Can that be kind of combined and made in a little nice compact form? So what would X to the 1/3 divided by X to the 1 be?
-2/3.
Oh, to the -2/3. So I'm gonna rewrite it. And then your question came up, do we assume it's always X over here? Well, we were using X's, so let's use another variable. Let's say Y. Let's just say Y, just because I don't want to use X and X and X. So X to the Y is equal to X to the -2/3. So what's the value of that?
What? Oh, excellent.
Because this guy to this power is this.
-2/3.
So -2/3 is your answer.
Yeah.
It's like a nice big puzzle, right?
So we're saying,
Okay.
so x
So this answer
So the answer is
is negative
X.
2/3.
Okay, it's just negative 2/3.
Yes, you may. So I'm putting up the properties over here. Okay, and so I'll leave them up here for you to copy when you get here. Sounds good? Okay.
Oh my god. There's a reason why no one likes logs.
I know.
They gotta get a better metaphor for the beach things, because you drop it and the things go. Get back here.
Because that's next time.
Is this two separate equations?
I liked Mario's section.
We should go back. There's 3 different. So this is 1, this is 2, that's 3. You can do this. She might knock on the door. I don't know if she's knocked on the door. Somebody knocking on the door? No, no. The little guy is always an A. No, you didn't have to figure anything out yet. I didn't need you to write him down.
Oh.
Like, I don't know how to do this. Well, it's just writing them down, yeah. We haven't gone there yet. Because remember, this is Friday, so I can do slow pace with you all, because 5th period, we'll probably only not even get to this, which is a bummer. Okay, so what we're going to be doing with these, and I would hope that you've seen this before, but if not, not a big deal. So what we're going to do is we're going to do things called expanding and condensing, okay? So in essence, what I've written over here, this is a condensed form. If I expand it, it becomes this. This is a condensed form. If I expand it, it becomes this, and so on. They're just formulas. I'm so proud of
Well,
you.
then I need to rewrite this.
I'm so proud of you. That's my kind of people.
We didn't get very far.
That's good. I didn't expect you to. I just wanted you to write them down. Ah,
Really had a whole revelation too. I mean, it was like,
you're so proud.
Expansion of the bigger one.
Well, I'm very proud of you as well. So, things to know is that your base here, when you expand, will also be the same guy base here. And then your little base here will be the same here. That's rather important, okay? Okay, so kind of keep that in mind. So let me explain how this goes. Right here, what I've written up here is 2 logs in what we refer to as an expanded form. You have the word log, you have a plus in between, and then the word log again. So we're going to try to condense it back. So this goes from condensed to expanded or expanded to condensed, okay? So if I'm looking at this, I want to bring it back together. Notice multiplication becomes addition. Hence addition becomes multiplication. You guys feel what I'm doing? Division becomes subtraction, whereas subtraction rewrites into division. I'll come back to this guy in a minute. So if I see this, the things that my brain goes through is, do I have the same little base? And what is the little base that I'm talking about up here?
2.
The number 2. So yes, I have the same base, I'm good to go. Now, in between these 2 words, log, I have what symbol in between?
Addition.
Addition. I can rewrite this in a condensed form by taking the word log and keeping the same base, and what shall I do with the 2 numbers that are out there?
Multiply.
Multiply them together. So what, I'll show it slowly. This would be 3 times 5, and then finally this answer would be log 2 of 15.
So we wouldn't have to solve it?
You would not. If I said now solve it, then you could. How would you go about solving?
Plug it in.
You would probably plug this in your calculator, right? You, Casio people, would literally plug this in. Us TI people would do log of 15 divided by log of 2, which is what we refer to as the change of base. because our base here is 2, and the calculator that I would have, the TI, does not understand anything but base 10. So when I change it out to be log of 15 divided by log of 2, my new base, the little guy, would be 10. So that's what happens when that happens. But your calculators, those of you that have Casios, it just does it for you, which, do you see that? I'm a little, wow. Okay, are we cool?
Yes.
All right, let me give you another one. So Abby, was this easier than what you thought maybe we were gonna do? Great, she made a little lesson plan right up in her mind, I'm so proud. All right, yay. I wanna take log 4 of 64 divided by P, and I want us to expand it. Okay, expand it. Asking you to expand it. So division means subtraction. So it's gonna be log, little base 4 of 64 minus log, little base 4 of P. How do we feel? Right? Sweet. All right. I am excited. Now, how do we start solving with these things? I'm gonna leave this up here. How do we start solving with this? Oh wait, let me just do one of those. Let's say I have log 2 of x to the 5th power. Okay? How can I rewrite it using that thing there? The 5 swings to the front. So this would be rewritten as 5 log 2 of x. Are we good? I think so too. So, let's solve for x. 2 log 8 of x plus 2 equals log 8 of 2x plus 19. Now, this is really cool, if you ask me. Let me do a little sidebar for this. Because that has a little bit more expansion going on. Okay, I'm going to do a more simplistic one first. So, the word LOG has what base? I've said it a few times.
10.
It has a 10. If I don't see it, I know it naturally has a 10. If it does, they don't put it here. It's kind of like an X, the number like 1x. We don't usually typically write the number 1. Does that make sense? So we don't write the number 10, but it's assumed we understand. If there's no little number there, it's going to be a 10. And so if I have the word LOG and it's something equals LOG and something. In other words, there's nothing in front. There's nothing that kind of that's got a little bit more going on. So if I look at this, I see that there's definitely not something in front of it. I can actually do what I call 10 it. Okay, so I can raise this to this power and this to this power. Yep, and what that does is it literally gets rid of the LOG word, okay? Because it's taking log, in other words, I'm not changing it because I'm doing it to both sides. And if you 10 both sides because it's LOG, it literally eliminates that. So what's left is 3x equals x plus 1.
So you basically raise both sides to the power of 10?
Yes.
Oh, okay.
You basically raise both to the power of 10.
Ms. K, does that work for the other one or just the 10?
You mean if they are,
Log of like 2, can we raise it to the second power?
yes, as long as your bases are the same power,
Okay.
okay?
So you raise it to whatever power the base is?
If they're the same.
If they're, okay.
So for that one right there, where it's the 2 log 8, if you were to raise it to the 8th power,
Would you also be raising the 2, or would
So
that?
that's why I did this one first, just to, cause, yes, but no, and let me show you why. So, do you see that there was nothing in front of here, right? So for me to be able to do this 10 thing, I'm gonna actually make sure there's nothing in front of it. And then I'm left with whatever those logs are, okay? So we could solve for this and we could get what 2x is 1 and x is 1/2 and we're good. Over here, I got a little hiccup. I got a 2 in front. However, I know how to take care of that 2 in front. What can I do to get rid of that thing out front? So I only have log of junk and log of junk.
You put it in the exponent.
Yes. Why can I do that? Because this tells me if 2's out front, I could rewrite it with 2 as an exponent. Does that make sense? So I can take this 2 and put it right there. So what I end up having is log 8 of x plus 2 squared equals log 8 of 2x plus 19. Now, do I have log of the same base on each side and then there, whatever it is? So now, literally, I ate both sides. Of course I ate both sides. Okay, so I do that, and then what's left?
There's an answer.
X plus 2 squared and 2x plus 19. Is that something we can solve? For sure. Just expand by foiling and then combine like terms. I'll let you play with that for a minute. We good? So, the only thing that I advise you to do is plug your values into the very original problem and make sure that they're good to go. Once in a great while, you're gonna find one that's like, I can't use that, okay? So go ahead and plug in -5 into the very original. So this guy was the very original, right? Go ahead and plug it into the very original and see how that works. And then tell me what happens. When I plugged in the -5, it was a no-go, done. But when I plugged in the 3, was that okay?
Yes.
There we have it, okay. What do we get out, 13 after? Yeah. I'll do one more. What do you guys think? Horrible, not so horrible?
It's
A lot
okay.
of algebra too.
Was a lot trying to be like an answer, but not our answer.
So it's not an answer.
Okay.
It's the only one that works is the other guy. Yeah.
So if we ever have like a negative answer, can we automatically just?
Not
negate it?
not necessarily, because this, like, let's say it's -5, but this could be a 7. So -5 plus 7 would be positive
Okay.
2. So LOG of a negative number is a no-go, but you could plug a negative number in and it could still be okay.
Okay.
So check it, okay?
It would be -3 by parentheses within the square.
Now, the only way you can E it or 8 it or 10 it or whatever you're doing it, right? It's the only way that can happen is if you have LOG equals LOG. Over here, I have LOG, LOG, and a 2 over there. So I can't just raise it to some power and be done with it. The only way that can happen is if it's that equals that. So now we have to think in our little memory bank, what techniques could I use for this? So there's multiple properties that I just erased up here. One of them was when 2 things were multiplied, you add. When 2 things are divided, you subtract. And then the other one was, and if I have something out front, I can make an exponent out of it. So if I'm looking at this over here, what's the first thing that kind of falls into my eyes and I'm like, oh, I should probably take care of that thing first? The exponent. So what number am I gonna put up as a new exponent? The 4. So step 1, bring that guy up. All right, are we feeling good so far? Now, what's the next thing I see?
It's subtract.
I have subtraction, and they both are the same base. So what do I know about two things that are subtracted? I can rewrite it with division. So the 2 words log become 1 word log, and I have 2 to the 4th over 4. Does 2 to the 4th over 4, can that clean up a little bit? 2 to the 4th is 16 divided by 4 is 4. So I'm gonna rewrite it. Now, what's that little technique that I showed you that you can take a log and rewrite it?
Base,
Little
equals
base.
the thing on the other side.
Base to what power? The 2 equals 4. What's x? 2. What do you think? Not bad at all, right? Good fun. Okay, I'm gonna call it good
Wait,
fun.
I have a question.
Yes.
So, Connor was saying that for the other problem, because you moved the 2 for the second part of the, you make it squared.
You have to plug it into the first part. If you plug it in here, it's gonna positive it, and it'll work. And you don't wanna do that.
Okay, you don't want it.
Oh.
It's gotta be from the